So I'm John Marshak. I've been with the Water Board since October of 1981. Started with the Central Valley Board, was involved initially in their first, quote, toxics unit. We started dealing with groundwater issues and toxic chemical pollution, and moved around to almost every program in the system through the Central Valley. And then in 2008, moved to the State Water Board to become the director of the California Water Quality Monitoring Council, which is an interagency effort to coordinate monitoring between agencies, share data, and to bring data and information derived from those data to the internet via the My Water Quality web portals. So you may have seen the My Water Quality button on the State Water Board homepage, and if you haven't clicked on it, look through and see some of the things we have, and we're adding to it all the time. And we need to add some stuff from Gamma, definitely. But that's another conversation. Okay. So the main concepts we're going to cover today: how to select numeric thresholds to assess our water resources. And of course, a lot of different things come into play in water quality assessment. Port of Cologne Water Quality Control Act, our statute, the Federal Clean Water Act that we have authorization from EPA to implement. And the term water quality standards is crucial to this discussion, and those standards for California are contained in plans and policies of the state and regional water boards. At the very end of the class, we'll discuss how the principles of anti-degradation affect the selection of numeric limits. So we're going to cover a number of statutes, regulations, plans, and policies that relate to water quality standards. We're going to look at how to implement our narrative water quality objectives using numeric thresholds from other organizations and the peer-reviewed literature. We'll look at the water quality goals resources available to you to help you understand water quality standards and to find a number of thresholds that can be used to interpret our water quality standards. There's the Water Quality Goals Staff Report, the database and online resources, and a number of algorithms that I've developed to help you select from among those thresholds the ones that are more defensible. Okay, before we get there, let me show you where to find all the course materials for this class. You really don't need to take notes because the staff report presents everything that's in the class. All the class slides are there, as well as videos from when I taught this class 4 years ago. And as you can see from our video setup today, we're going to replace the videos with new ones in the near future. So to find the water quality goals materials, you click from the State Water Board's website on Water Quality Assessment. And then the second item under Water Quality Assessment is a compilation of water quality goals. On that page, there's the third link is staff report and training videos. So here is the staff report that it presents in written form all the material that you'll be hearing today. And then there's an introductory video about an hour long, as well as the videos from the entire class. The PowerPoint slides are here. The course agenda is here. So as I said, you really don't need to take notes. In fact, I think it'd be better if you sit back and listen, because there's going to be a lot of material coming your way. Well, I'm sure this is obvious to all of you being water board employees. And by the way, is there anybody here who's not a water board employee? Okay. That California is a state that is water limited. And because of our unique relationship with water, we have a set of standards, regulations, plans, policies, statutes that set up a system for water quality protection that is different than what you find in most other states and at the national level. And first and foremost among those is our statute, the Port of Cologne Water Quality Control Act, enacted by the state legislature in 1969. before EPA was created. It's found in Division 7 of the California Water Code. How many people have actually opened up Port Cologne and read it? Oh, quite a few. That's good. My very first task when I started working for the Central Valley Regional Water Board, I was given my office and given a copy of Port Cologne and the Basin Plan, and I was told to spend 3 days just immersing myself. And I would suggest if you haven't done that, that you spend some time doing that, because there's a lot of wonderful information there. I'd like to go over the very first part of Port Cologne. When the legislature adopts a new statute, particularly one as important as the Port Cologne Water Quality Control Act, they start with a number of legislative declarations that essentially set the stage for what the legislature is trying to do with this new piece of legislation. So it gives you a flavor for what we're all supposed to be doing in our jobs. So first of all, it states that the people of the state have a primary interest in the conservation, control, and utilization of water resources of the state, and that the quality of all waters of the state shall be protected for use and enjoyment by the people of the state. So in other words, it's a public trust resource that we are trying to protect. It isn't owned by an individual who happens to own land that a stream goes through. All the waters of the state are owned collectively by the people of the state and are to be protected for their use and enjoyment. The declarations go on to say that activities and factors that may affect the quality of waters of the state shall be regulated to attain the highest water quality which is reasonable. The word reasonable is something you see a number of times in our statutes, in our regulations, in our plans, and our policies. Something a little different than you see in federal counterpart legislation and regulations, and we'll talk more about that a little later. But in order to figure out what's reasonable, Port Cologne says we have to consider a number of things. All demands being made and to be made on those waters, the total values involved, beneficial and detrimental, economic and social, tangible and intangible. Water quality is a really difficult area, and people have a lot of different perspectives that come to bear on how much we protect our water resources, to what degree, what is reasonable in protecting our waters, for which uses. And for this reason, Port Cologne has its major implementation through the 9 regional water boards rather than from a single state agency. And all of the decisions that are made, whether it's to adopt a permit or an enforcement order or to change our water quality standards, is done through public hearings by a board that represents a broad variety of interests that come to bear on water quality. So it's difficult to juggle all these different factors, and the legislature thought that this system of boards in a regional setting with the State Water Board providing oversight was the best way of factoring in all of these differences around the state. The declarations go on to say that the state must be prepared to exercise its full power and jurisdiction to protect the quality of waters of the state from degradation. So the term water quality control really is what we're all about. And Port Cologne has a definition section at the very beginning, right after the declarations. And the definition of water quality control is the regulation of any activity or factor that may affect the quality of waters of the state, and includes prevention and correction of pollution and nuisance. So again, further refinement of what our roles are in protecting water quality, but actually giving us very, very broad authority. Any activity or factor that may affect the quality of waters of the state, including prevention and correction of pollution and nuisance. A lot of different things can be regulated under this water quality control umbrella. And then the 2 things, pollution and nuisance, that we're supposed to prevent and correct are also defined. Pollution being an alteration of the quality of waters of the state by waste to a degree that unreasonably affects the beneficial uses of water or facilities that serve those beneficial uses. So again, the word reasonable is brought in. And protecting water quality from waste. And then it goes on to say that pollution may include contamination. Who can tell me the difference between pollution and contamination? It's one key factor that contamination requires, and that is a public health impact. So you see our drinking water folks in the Division of Drinking Water talk about contamination of water and looking for contaminants of concern because they're primarily focused on protecting human health. Pollution is much broader than that. So contamination is a subset of pollution. It's important to use the terms correctly, and that if you're talking about something broader than human health concerns, that you use the word pollution. Nuisance is the second factor that we are supposed to prevent and correct if it occurs. And nuisance is a little more complicated than pollution because it requires a number of things to happen at the same time. First of all, it needs to be injurious to health or indecent or offensive to the senses, or an obstruction of the free use of property so as to interfere with the comfortable enjoyment of life or property. Again, pretty broad language, pretty broad authority. But at the same time, it needs to affect an entire community or a neighborhood or a considerable number of persons, realizing that everybody has a different view, for example, of what might taste bad or what might smell bad. Our senses aren't all tuned into exactly the same frequency. We have different degrees of discomfort from various things that might cause nuisance. And so we want to make sure we aren't necessarily protecting the most sensitive individual, but if there are a number of people that have a problem with some sort of nuisance activity, then that's where we step in and can take action. And then the third thing that has to happen for it to be a nuisance is it has to occur during or as a result of the treatment or disposal of waste. So again, waste comes into the picture as further defining our authority, preventing pollution and nuisance from the treatment or disposal or discharge of waste. Here's a term you will not find in Port of Cologne, water quality standards. A lot of people think they know what water quality standards mean. It's a very complicated term. The place where you actually find a definition is in federal statute, the Federal Clean Water Act. Portions of which, by the way, were patterned after Port of Cologne. And water quality standards are defined in the Clean Water Act as provisions of either state law or federal law that do two things: designating use or uses of waters of the United States and water quality criteria to protect those uses. So you have to know what the uses are and then criteria to protect those. And taken together, if they're found in a state or federal law, they are water quality standards. Now, the term waters of the United States is what's covered by the Federal Clean Water Act, and that is somewhat limited in that the definition of waters of the United States is navigable waters and their tributaries. At the federal level, water quality control all started with maintaining routes of navigation. And any obstruction to navigation was initially the focus of water quality control programs. It's, of course, since been broadened, and with the Clean Water Act, very much broadened. But still, the focus is navigable waters and their tributaries. So a vernal pool that has no direct connection to a navigable water by tributaries is not a water of the United States, and the Clean Water Act does not apply. But in California, we use a different term, and I'll get to that in a moment, that's much broader. Also, with respect to waters of the U.S., there have been a number of Supreme Court decisions that have challenged EPA's broader interpretation of waters of the U.S. and narrowed it quite considerably. Currently, there's an effort underway between U.S. EPA and the Army Corps of Engineers in order to clarify a somewhat broader definition than was assumed to occur from those Supreme Court cases, but also could be interpreted to comply with those cases. Okay, so in California, our water quality standards, the uses to be protected and the criteria to protect those uses, are found in our water quality control plans, including the basin plans adopted by the State Water Board and the 9 regions. And they include beneficial use designations, California's term, for each body of water or a portion of a body of water. So a certain reach of a stream might have certain uses associated with it that don't apply to other reaches of the very same stream. And then the criteria to protect those uses we call water quality objectives. Port of Cologne requires an additional implementation program. Whenever we have water quality objectives, we need to have a plan for how to achieve compliance with those objectives. So implementation programs are also in our basin plans and our other water quality control plans, and is a requirement of Port of Cologne, not the Clean Water Act. So in contrast to waters of the United States, waters of the state includes both surface water and groundwater. Because we designate beneficial uses for surface water and groundwater and vernal pools, we effectively have water quality standards for those, because we also adopt water quality objectives, the criteria to protect those uses. Water quality standards are there to protect not only existing patterns of water use, but future patterns as well, probable future uses of water. And because of that, our water quality standards apply throughout the body of water for which the beneficial uses have been designated, not just at the current point of use. So for example, if we have a water quality objective that prevents adverse tastes or odors in groundwater, that applies throughout the aquifer for which which beneficial uses have been designated, not just where the current wells are. Because we're trying to protect a future pattern of use of that aquifer. If somebody pops in a new well in a new location, our job is to make sure that water is of a quality that would support the uses that have been designated in our water quality control plans. So beneficial uses are also defined in Port of Cologne as those uses that may be protected against water quality degradation. And it gives some examples, but not an exhaustive list. First of all, designating a number of water supply uses: domestic, municipal, agricultural, and industrial; power generation, recreation, aesthetic enjoyment, just walking along a stream and enjoying the water flowing by; navigation, and preservation and enhancement of fish, wildlife, and other aquatic resources or preserves. The regions and the State Water Board have gotten together and clarified definitions of beneficial uses. I think the last time it was done statewide was in 1996, where through the Basin Planning Roundtable, the definition of beneficial uses was made the same wherever those beneficial uses are found, whether they be in one region's basin plan or a State Water Board water quality control plan. The definitions are all the same. Since that time, several regions have added new beneficial uses, and you'll see some of those coming up that other regions would be encouraged to use. So again, we start out with a number of types of water supply. Municipal and domestic supply being first. What's the difference between municipal supply and domestic supply? Groundwater folks ought to know this one. If you're thinking of groundwater, what kind of wells do you find for domestic use rather than municipal use? What's the difference in the kind of wells that you might find?
Shallow and private.
Domestic use, shallow and private, because that's all that they can afford. Because you're talking about less than 15 connections, less than 25 persons, not regulated by our water quality standards from the drinking water program, but they are regulated through the quality of the groundwater is regulated through our water quality standards from our water quality control programs. And municipal wells tend to be deeper, larger, drawing more water at once. So knowing that difference, domestic wells being shallow, pulling in a smaller amount of water from the aquifer, versus a municipal well, draws in a lot of water, is deeper. Which one's more vulnerable to pollution? from things we do on land. Domestic is more vulnerable, because of those characteristics. And we're supposed to be protecting both. So whenever MUN is designated for a body of water as a beneficial use, it means municipal and domestic supply.
Municipal, does that also encompass private wells as well?
Does municipal encompass private wells as well? Actually, it's intended to cover those water supplies that are regulated by our drinking water program in the state. So that would be a water supply source that serves 15 connections or more, or 25 persons or more. Domestic is smaller than that. Also, with domestic supply, many of those sources are not treated, or they're minimally treated prior to direct use. So somebody who has their own well, their own private well behind their home, that water might be chlorinated, usually not. It might be filtered, often not, but definitely not treated to remove chemical pollution. Okay? So again, more of a vulnerability of the user of the water on the domestic supply end than you have at the municipal supply end. Agricultural supply, so we're talking there about both crop irrigation and watering of livestock. Industrial supply is broken down into service supply and process supply. Who knows the difference between those two? Got a shy group today. So the difference between process supply and service supply has to do with whether the quality of the water is important to the product being produced by the industry, or whether the water is simply used for a process such as cooling, where water quality is not as important. Okay. Groundwater recharge, freshwater replenishment. This is the replenishment of our surface waters and our groundwaters from upstream and upgradient. Navigation is a beneficial use. Hydropower generation. Okay, another question for you. Recreation is broken down into contact rec and non-contact rec. What is special about contact recreation that requires greater protection?
You can ingest it.
There is the chance that in the process of recreating, you will ingest a certain amount of that water. Usually the focus there is pathogens, so bacteria, viruses, those kinds of things. So then we have a number of ways that aquatic organisms are harvested: commercial and sport fishing, shellfish harvesting, subsistence fishing. Realize there are certain communities around the state that depend more on local fisheries for their protein than do the average person in our population. And because of the process of bioaccumulation of pollutants from water through the aquatic food chain, and us being top predators, those people are exposed more to bioaccumulated pollutants than the average person, and we need to be protecting them as well. Aquaculture, the harvesting of things grown on purpose in our aquatic environments. And then we have a number of habitats. Freshwater habitat is broken down into warm water habitat, cold water habitat. This one I'm sure you guys know. What is special about cold water habitat? What kind of organisms are we talking about that we're protecting there? What kind of fish? Salmon, salmonids, right. Salmon, steelhead, those fish that migrate from fresh waters out to salt waters and come back again normally require what? Two things. Two factors of water quality that salmonids require. Temperature, colder temperatures, and more dissolved oxygen. Okay. So you'll find the water quality objectives for cold water, freshwater habitats will require lower temperatures and higher DO levels. Then we have estuarine habitats where our freshwaters and our saltwaters come together. Very important for a number of processes, including rearing of juvenile aquatic organisms, filtration of pollutants as they migrate to the sea. A number of things happen in our estuaries. Then we have inland saline water habitats. Think of the Salton Sea, for example, or Mono Lake. Marine habitats, wetland habitats, wildlife habitats. Wildlife is a tricky one because you have to constantly bring it back to what's the effect of water quality in order to understand what wildlife habitat beneficial use means. I had an instructive story about that very early on in my career with the Central Valley Water Board. In the early 80s, we had a landslide up on the Feather River Canyon that pushed a bunch of transformers into a reservoir. And the transformers broke open and they contained polychlorinated biphenyls. So we had to try and figure out how much cleanup do we need to protect all beneficial uses. Wildlife habitat was the most important, the most limiting factor. And the Department of Fish and Game, now Fish and Wildlife, helped us figure that out. And again, it was bioaccumulation. PCBs bioaccumulate up the food chain. We are trying to protect top predators, bald eagles that were nesting in the canyon, that would eat mink, that would catch fish, that would accumulate PCBs from zooplankton, phytoplankton, all the way down to absorbing it from the water. So by back calculating through all those bioconcentration factors, we calculated what was the cleanup level needed in that reservoir. So again, wildlife habitat has to relate back to water quality. Then we have preservation of areas of special biological significance, ASBS. Anybody here in the marine program? Marine water quality? Anybody can tell me what ASBSs are? They are special places along our coast where, in order to protect certain species, we've decided that we need to maintain existing water quality. Discharges that would change the quality of waters within an ASBS are prohibited. Exceptions can be made if the discharge is found not to significantly alter the existing water quality. So it's applying a standard more stringent, more along the lines of our anti-degradation policy, which we'll talk about later on. Then we also have preservation of rare, threatened, or endangered species, migration of aquatic organisms, again think salmonids, spawning, reproduction, and or early development, where life stages might be more sensitive than they are at other times. And then a number of regions, I believe starting with the Lahontan region, began adding beneficial uses that relate to wetlands. A couple of uses that are very important for our wetlands is water quality enhancement. As water flows through a wetland, the biological processes that are going on filter the water and remove a number of pollutants of concern. So being able to maintain that process of enhancing water quality as it flows through a wetland is a beneficial use that now the Lahontan region recognizes in their basin plan, and I believe the North Coast and San Francisco Bay regions are in the process of adding a similar beneficial use. And then another wetland or riparian area beneficial use is peak flood attenuation and floodwater storage. So if you think about a narrow water channel, as we get a peak flow through, it spills over into the riparian areas, and then after the peak has subsided, can slowly trickle back into the main channel. And that helps protect downstream areas from flooding. So again, a beneficial use of riparian areas and wetlands that we need to protect. The North Coast region has also adopted a beneficial use Native American culture. There are certain religious practices of our Native American tribes that rely specifically on a certain water quality. For example, in the Yurok, which is up on the Klamath, the tribal members collect freshwater mussels. And part of their cultural practices involve ingestion of those freshwater mussels. Freshwater mussels can bioaccumulate pollutants from the water, particularly things that are created, the pollutants that are created from our harmful algal blooms and the cyanotoxins that come from those harmful algal blooms. There are other practices that involve immersion in water, that involve pulling reeds through the teeth in order to create the fibers necessary to weave baskets. These all rely on a certain quality of water to be maintained so that they can continue with their cultural practices. And so this beneficial use has been added by the North Coast region. This has become an issue much more broadly being recognized in the state of California, and so the State Water Board is actually in the process of considering the adoption of 3 new beneficial uses that would be available to all the regions to designate for individual waters. And that is, first of all, California Indian tribal traditional and cultural beneficial use. That's very similar to the Native American culture that we have in the North Coast region already. California Indian tribal subsistence fishing, realizing that certain tribes tend to eat more fish and other aquatic organisms as part of their normal practices, and because of bioaccumulation, we need to keep pollutants at a lower level in order to protect that amount of fishing. And then a non-tribal beneficial use of subsistence fishing, recognizing that there are other communities within our state, for example, the Hmong who live in the Sacramento-San Joaquin Delta, that rely very heavily on fish from those water resources for their protein in their diet and eat a lot more fish than the average person does. Okay, this is factoring heavily into the development of water quality objectives, statewide objectives for mercury, for example. Okay, in addition to the beneficial uses that you find in our water quality control plans, our basin plans, we also have a policy for water quality control adopted by the State Water Board back in 1988. This was adopted shortly after Prop 65 was approved by the voters as an initiative statute. Prop 65 did a number of things, but it said that it was illegal to discharge a significant amount of a carcinogen or reproductive toxin to sources of drinking water. But the Prop 65 statute did not define what sources of drinking water meant. So the State Water Board stepped in, adopting a policy for water quality control. That's policy with a big P. Port of Cologne authorizes the regional water boards and the State Water Board to adopt policies of water quality control that have the force and effect of regulation. So it's just like you were looking up in Title 22 or Title 23 or Title 27. This policy is a regulation and requires that people abide by it without violating the law. So this sources of drinking water policy helped to define what the term meant by saying that all surface waters and groundwaters of the state are considered suitable or potentially suitable for municipal or domestic water supply. In other words, they are sources of drinking water with certain exceptions. Waters with high salt content, total dissolved solids greater than 3,000 milligrams per liter. Waters with contamination, health impact, unrelated to a specific pollution incident that cannot reasonably be treated for domestic use using best management practices or best economically achievable treatment practices. Sources with low sustained yield. So think of water in a clay-rich subsurface formation where you just can't get 200 gallons a day when you stick a well into that formation. That would not be a source of drinking water. Also, wastewater conveyance and holding facilities, whether they be municipal, industrial, or agricultural, are not considered sources of drinking water. Same thing for regulated geothermal groundwaters because of the high mineral content and toxic things like selenium and arsenic that might be present in those waters. Now, 8863 required all of the regions to amend their basin plans to incorporate this new policy for water quality control. So you can imagine the task at hand of trying to figure out whether each of these exceptions might apply to waters that the regions had never assessed before. Well, there wasn't funding for that, so most of the regions simply implemented the first part of the policy, which essentially broadened the applicability of municipal or domestic supply use to all water bodies that weren't specifically designated in their water quality control plans or basin plans. Okay, so what that did was to set up a conflict, because we'd find out later on that certain of those waters would be eligible not to be sources of drinking water under one of the exceptions in this policy. But the standards had already been set by the change that was made in the basin plan to comply with this. So what the region could do, for example, if it found that somebody didn't want to have to comply with a water quality objective for a water that was very saline, is the region would have to go back and actually amend the basin plan to remove the municipal or domestic supply beneficial use, using these exceptions in this policy as the rationale for doing so. But until that's done, the regions are required to protect those uses. Any questions about policies for water quality control, or this one in specifically? Yes?
So it says the exemptions include industrial and agricultural wastewater conveyances.
Right.
So is that part of like this? I mean, why is that exempt? I imagine
So the question is, why are wastewater conveyances not considered a source of drinking water? So let's say we're talking about an agricultural drain where tailwater that runs off of fields flows down a channel, a man-made channel, that eventually discharges into a water of the state. You're not going to find that either domestic or municipal supplies will tap that agricultural drain because of the pollutants that are likely in it, whether it be high solids, high salt, or pesticides or fertilizers that might be in those waters. So this policy recognized that those agricultural drains also are sewers, are municipal drains, aren't sources of drinking water either, and same thing with industrial drains. So wastewater conveyance or holding facilities, a holding facility might be a pond at a dairy that holds the waste from the cows, would not be a source of drinking water.
So when it comes to wastewater, it seems like it's more enforced on a county level then. The state.
The enforcement happens, the question was, is it enforced at a county level or how is that done? The enforcement happens when that drain discharges into a stream, a river, a lake, or percolates water into the subsurface and might affect the quality of groundwaters. So that's the point at which our water quality control protections come in, protecting beneficial uses of those receiving waters for whichever beneficial uses have been designated. Okay. There is some disagreement between us and US EPA over this whole issue of agricultural drains. US EPA has at times considered agricultural drains to be tributaries and therefore protected under the Federal Clean Water Act. In most cases, California has disagreed with that, and it's not totally been resolved yet. But if you think about it, many of the agricultural drains we have today started out as creeks, and they were straightened, they were dredged, and then turned into an agricultural drain. So they may have started out as a tributary of a stream or a river. Okay, so that's still under debate between US EPA and the state and regional water boards. Okay, the second part of our water quality standards are the water quality objectives, limits or levels of water quality constituents or characteristics established for the reasonable protection of beneficial use or the prevention of nuisance. There's the word reasonable again. So water quality objectives, before a regional water board or a state water board adopts a water quality objectives, one of the findings that it has to make is that that objective is reasonable to achieve. If we can't make that finding, we legally cannot adopt that water quality objective. Now, for surface waters that are also covered under the Clean Water Act, We have delegated authority from EPA to implement the Clean Water Act. Any water quality objective that's adopted for waters of the United States by a regional water board or the state water board has to be approved by US EPA before it becomes effective. And EPA is not looking at this definition. They're looking at their definition of water quality criteria under the Clean Water Act, which essentially requires water quality criteria to be fully protective of the use regardless of whether it's achievable. So there are times when a regional water board or the state water board adopts a water quality objective that EPA says, not fully protective, go back and make some amendments. And we have a debate back and forth about how that should happen. So it's a conflict that's set up between this definition and the definition of water quality criteria under the Clean Water Act. Okay? So more about that when we talk about the California Toxics Rule. So water quality objectives come in two forms. They're either numeric, usually specifying a concentration limit or a range of values that we have to maintain, or they're narrative, describing a requirement or prohibiting a condition that's harmful to beneficial uses with a certain amount of language, but not numbers necessarily. So my experience, as you've heard, is mainly Central Valley region. I'm familiar with the basin plans of nearly all the regions, but my examples tend to be drawn from where I'm most comfortable. The Central Valley region basin plans, that for the Sacramento and San Joaquin River drainage and for the Tulare Lake Basin as well. So those two basin plans have numeric water quality objectives for all of these constituents and parameters. So actually a concentration limit or a numeric value. But there are also a number of narrative objectives that you find in the Central Valley region basin plans that have similar, they're similar to objectives in all of the other basin plans all around the state. And I'll try and point out some of the differences that you see between these. So the first is chemical constituents. It essentially says that you can't have chemicals in concentrations that adversely affect beneficial uses. Very broad. So if this has been applied to a surface water or a groundwater, this language gives us a tremendous amount of authority to prevent certain constituents from getting into water at concentrations that would do a number of things affecting beneficial uses. I'll give you an example. Let's say that somebody is using a borate-based cleaner. You've heard of Boraxo. And they have discharged that cleaner to the ground, and it gets into a local creek. That creek is designated for agricultural supply as one of the beneficial uses. Boron can cause a reduction in crop yield. It can even kill certain crops and other plants. So if the boron concentration gets high enough to reduce crop yields or kill plants, that water being designated agricultural supply is a violation of this water quality objective. And our job would be to document how much boron got into the water and what are the levels of boron that could adversely affect crop yields or could kill certain crops. We put that together in findings for an enforcement order that we then take to our boards. Okay? This language gives us very, very broad authority to protect waters from a lot of different things. The chemical constituents objective in most basin plans also talks about how maximum contaminant levels, the drinking water standards, also apply to our ambient waters. So most regions have, under their chemical constituents objective, language that says, at a minimum, waters designated for use as domestic or municipal supply shall not contain concentrations of chemical constituents in excess of the drinking water maximum contaminant levels. So think again of domestic supply, which isn't necessarily treated prior to use. We want to make sure that the burden of pollution isn't transferred from the polluter to the user of the water by requiring that those MCLs for chemical constituents are met in the raw source water. Okay? And most of our basin plans do that, both for surface water and groundwater resources. And then something that was added to the regional basin plans in the Central Valley in the mid-1990s, just for clarification purposes, is that to protect all uses, the Regional Water Board may apply limits more stringent than MCLs. So think of aquatic life protection from copper. Fish are a lot more sensitive to copper than humans are. So an MCL is not going to protect all beneficial uses. And the regional boards need to apply limits that are protective of all uses. Another very prevalent narrative water quality objective you find in all of the basin plans for surface water and in some basin plans for groundwater is an objective for toxicity that essentially says no toxic chemicals in toxic amounts. Okay? You have to think of the beneficial uses in order to figure out how to interpret this objective, because it's going to be different depending on which beneficial use you're trying to protect. If the beneficial use is municipal or domestic supply, you're trying to protect humans from toxic effects, from, in this case, detrimental physiological responses. If we're talking about agricultural supply, we're protecting plants, we're protecting livestock, again, from toxic impacts. If the water is designated as freshwater habitat, then it's the aquatic organisms that we're trying to protect from toxic impacts. So the numbers might be a little different that you use depending on what the beneficial uses are. So it's really important, think of more globally, the standards are the use and the objective together. And you really can't understand what the standard means until you take them together. Something that the Central Valley region added, again, it's there, it's available to everyone, but the Central Valley region thought that we should have a very specific piece of language that made it obvious that toxicity doesn't just mean from a single chemical, but it might mean the interactive effects of multiple chemicals together. Let's say we had a carbamate insecticide and an organophosphate insecticide together in water. Each was below its toxic threshold. But because those two chemicals implement their toxic effects exactly the same way on the central nervous system by interfering with cholinesterase, one of the enzymes that's important for nerve transmission, those two chemicals together might have a toxic impact where each one separately might not. And the toxicity objective can be interpreted to protect against that interactive toxicity. So here's an example of how the numbers might be different depending on which beneficial uses and which organisms related to those beneficial uses we're trying to protect. So if we have humans that we're trying to protect for municipal and domestic supply or contact recreation, it might be, well, for drinking water purposes, the maximum contaminant level. If we're trying to look at whether there's any detrimental physiological responses, we might also think of the public health goal. There's a difference between MCLs and public health goals. Public health goals are what is the amount that we're assured there will be no adverse toxic effect on human consumers of that water over their lifetimes. The MCL is derived starting with that number, but factoring in various aspects of enforceability of the number. Can you quantify it by analytical methods that are generally available throughout the state? Are there situations of cost that need to be brought into the picture? Because an MCL applies in drinking water systems throughout the state, the same number. Okay, so if we're trying to implement our chemical constituents objective that says you got to meet MCLs, we'd look at the 1300. But if we're trying to implement our toxicity objective, the public health goal might actually be a more reasonable number to use. And I'll talk more about that in a little bit. But if we're trying to protect aquatic life habitats, the California Toxics Rule criteria to protect aquatic organisms, freshwater aquatic organisms, requires a level of copper that is a couple order of magnitudes lower. It varies with the hardness of the water, from 2.7 to 29. Does anybody know why Toxicity of copper might vary based on the hardness of the water.
How hardness can be interpreted?
What is it about hardness that might make copper less toxic in harder waters?
Less of it dissolved?
It's a matter, dissolved is part of it. So it's a matter of if we have harder water, there are other constituents that can form complexes with the copper. So it isn't just free copper ions that are in the water. The most toxic form of copper to aquatic organisms is the free copper ionic form. But if the copper is in complexes with sulfate or carbonate or something else that would be more prevalent in harder waters, the toxicity of the copper goes down. So you can actually have a higher criterion and still be protective in harder waters. So that's where the 29 comes from. The 2.7 is in softer waters. And there's a gradation in between that I'll show you later on graphically. Also, if we're protecting agricultural use of water, there are certain crops that will have lower sustained yields beginning at about 200 micrograms per liter of copper. Okay, so if we're protecting agricultural use of water, again, we might need a number more stringent than the MCL. And I did mention that only some of the regions have a toxicity objective for groundwater. Central Valley region has it. I believe the North Coast region just added it within the last few months. The Santa Ana region has a toxicity objective in their basin plan for groundwater. And I think San Francisco Bay might have one as well. Not sure on that last one. Yes?
How are the numbers determined, and do they ever change, or can they be changed if new?
So the question is, how are the numbers determined? So there are two things we have to consider in implementing our water quality objectives. The numeric objectives are easy. They don't require us to do any effort at all. Just grab the number out of the basin plan, apply that, you're done. Those numbers can only be changed through a basin plan amendment, and a basin plan amendment is a regulation change. So you have to go through the public noticing, public hearing, comment, response to comments, adoption in a public hearing. And then those, again, have to be confirmed by US EPA if they're for waters of the US. Also, the Office of Administrative Law comes in as verifying that our process was appropriate in adding that new regulation. So it's hard to change those numbers. This is where our narrative objectives are more powerful, because the narrative objectives simply say no toxic amounts, no adverse tastes or odors, no chemicals in concentrations that would interfere with any beneficial uses. It leaves it up to the regional boards and the state water board to figure out what number is the best number to use. So we can look at newer values that might be available, but we have to justify their use for this purpose. In the permit that we're writing, in the enforcement order that we're bringing to the board, we would need findings to demonstrate this is the most appropriate number to apply this narrative water quality objective. Does that answer your question? We'll talk more about that later on in the class, where the numbers come from and how they're derived and how they might change over time. Okay. Yes?
You mentioned in your last slide about the ag use and that some crops have lower thresholds. Do you have to consider all crops or just what's being grown at that point?
The question was, if we're considering protecting agricultural use, what kind of crops do we consider? The ones that are currently grown there or ones that could be grown there? Well, think about, we're protecting existing use and probable future use of water. So it's not just what crops are currently being grown, being irrigated with that water, but what might be grown in a probable future scenario. So what crops could be grown in that climate, in that soil, with that amount of sunshine and rainfall or irrigation water available, all those different factors, but not just what's currently grown, because we're protecting future use as well. Good question. Thank you for bringing that up.
Hey, John.
Yes?
Just to clarify, so taking that into consideration, what Jarma said, could the ag limit vary then based on whatever the future probable use could be?
So the question is, could the ag limit vary depending on what the future probable use might be? So there is a document that I'll mention a little bit later on, but I'll bring it up now since the question came up. There's a document called Water Quality for Agriculture, published by the Food and Agriculture Organization of the United Nations. Dennis Westcott, supervising scientist from the Central Valley Water Board, now retired, was one of the two authors of that document. And that document lays out numeric values above which certain specific crops will start showing lower sustained yield. Things that are more sensitive might be strawberries, might be citrus, tend to be more sensitive to certain things than other. And it depends on the pollutant as well. So depending on which crops you figure out might be able to be grown in that area, the numbers might vary.
What was the document called?
Water Quality for Agriculture by the Food and Agriculture Organization of the United Nations. And I'll show you where you can find that document online a little bit later on in the class. Very valuable resource. Okay, tastes and odors. Another narrative objective. You'll find this in every basin plan for surface water and groundwaters. If something is added to the water that makes the water taste bad or smell bad, you've interfered with the beneficial use of the water, whether or not it's toxic. So we all have we all have water quality objectives that apply in every region that bar adverse taste or odor producing chemicals that would affect the water supply, would affect fish flesh or other edible products of aquatic origin, would cause nuisance or otherwise adversely affect beneficial uses. Again, very broad powers that these narrative objectives give us in order to protect water quality. So here's some examples. 3 constituents of gasoline and 1 somewhat notorious gasoline additive, MTBE. So the drinking water standards, the primary drinking water standards in this case, are all based purely on health effects. They've not been adjusted based on technology or economics. They're health protective numbers. But look at the taste and odor thresholds. In the case of xylene, water is going to taste bad or smell bad 2 orders of magnitude lower in concentration than it causes toxic effects on humans. We can implement these numbers if we justify them appropriately to our regional water boards, citing the narrative tastes and odors objective. In the case of MTBE, the taste and odor objective is also an MCL, but it's the secondary MCL, protecting human welfare. So we have 2 ways of using that 5, through the taste and odor objective and through the chemical constituents objective that requires compliance with all MCLs. Some regions also have a pesticide objective. This parallels the chemical constituents objective, but focuses more just on pesticides. Central Valley region has it. A couple other regions might have it. I think the Central Coast has a similar objective that essentially says we can't have pesticides in water, sediment, or aquatic life in concentrations that adversely affect beneficial uses. You can't exceed MCLs for pesticides where they exist if the water is designated municipal or domestic supply. In the Central Valley region, it goes on to say no total persistent chlorinated hydrocarbon pesticides in detectable concentrations. At the time this was adopted, the health effect levels were lower than what most labs could quantify. And so this is why the language was put into the basin plan the way you see it there. Since that time, our analytical capabilities have gotten much better, and we can quantify at a reasonable cost much lower concentrations, in some cases down to the health protective thresholds. So this particular objective keeps getting more stringent with time based on how well the labs are able to do. And then again, can't exceed the levels that are technologically and economically achievable. Very similar language to the chemical constituents objective. So for regions that don't have a pesticide objective, they could simply rely on their chemical constituents objective to essentially do the same thing, with the exception of this chlorinated hydrocarbon pesticide phrase. So there are other narrative objectives for a number of other constituents and parameters in your basin plans. How many of you are from a regional water board? It's really important that you read your basin plan and find out what it says. because you'll find all kinds of gems in there that give you tools to do your job. It's really important to know what's the language that's used in order to describe the kind of protections necessary for water quality, and then be prepared to justify using those in the orders that you bring to your board. And for those of you at the State Water Board, you've got a more difficult job because you've got all the different basin plans around the state to be looking at, as well as the statewide water quality control plans. Become familiar with what they say. They give us the tools to do our jobs. Switching gears for a few minutes to the realm of water rights. Vicki Whitney, who used to be in charge of water rights before she was in charge of water quality and before she then retired, took this class and said, wait a minute, you're using terms in a way that's different than the way we use them in the water rights realm. And so she helped me put together a number of slides that describe this difference. And I bring it to your attention just that you realize if you're talking to somebody who works in the Division of Water Rights, they're going to be talking about terms in a slightly different way. So, in water rights, the main task at hand is allowing or disallowing, or how much to allow, the appropriation of water out of a stream, a river, or a lake for use elsewhere. And those uses that are allowable under a water right permit are beneficial uses. But that term beneficial uses doesn't mean the beneficial uses in the basin plan. It means what you see here. So water can be appropriated through a water rights permit only for these purposes or to be stored prior to one of these beneficial uses. The terms are similar. They're a little different than what you see in your basin plan as far as the uses designated for each body of water. But when you're talking to a water rights person, they're talking about these beneficial uses, the allowable uses for appropriation of water from a water resource under a water rights permit.
Where are those defined?
Those are defined in regulations implementing the portion of the water code that affects water rights. Okay. Also, under its water rights authority, the State Water Board, now the regions don't have water rights authority, it's the State Water Board that has this authority. They can adopt water quality objectives specifying flow or operational requirements related to appropriation of water for beneficial uses. Again, the beneficial uses with respect to water rights. So, for example, the Bay Delta Water Quality Control Plan, which is a State Water Board water quality control plan, specifies how much water the Bureau of Reclamation and the Department of Water Resources can divert from the Sacramento-San Joaquin Delta to put that water into the California Aqueduct or the Delta-Mendota Canal for use by the various water contractors down the aqueducts. Okay? And so flow can be limited using a water quality objective that's specific to flow. Very clear from the regulations under water rights that the State Water Board has that authority. It's not clear that the regional water boards have the authority to adopt flow-related water quality objectives. Some regions believe they do because flow and quality, of course, are interrelated. And so this is being challenged now, I believe, first of all, in the North Coast region, where they're looking at actually trying to adopt some flow requirements as water quality objectives in their basin plan. And we'll see where that goes. So the State Water Board can manage their water rights to ensure that not only these flow objectives, but water quality objectives in our basin plans can be met. The regional water boards, according to the water rights folks, don't have the authority to implement the flow required water quality objectives. And because it's not covered under the Clean Water Act, EPA has no authority to approve flow objectives under the Clean Water Act authority. Okay, so a little bit difference between the water quality realm and the water rights realm. There is a condition in every water rights permit that allows the State Water Board to modify the amount of water diverted on the fly. And this was done during the drought, where certain water rights were curtailed, ramped back, or even eliminated altogether because of the drought emergency. In order to do that, the State Water Board has to do two things. It first of all has to find that it's necessary to limit those diversions to meet water quality objectives in the basin plans. And second, that it has to make a finding that there's first adequate WDRs prescribed on all waste discharges, and that water quality objectives cannot be achieved solely through the control of waste discharge. If they can make those findings, and it's necessary to meet water quality objectives in the basin plan, then they can modify water diversion in water rights permits on the fly. Okay? And there have been a number of court cases that have refined this authority over time. Okay, so that's all I was going to say about water rights. Just realize they use the same terms a little differently than the way that others would use them. Okay, California Toxics Rule. So we've talked mostly about water quality standards that have been adopted by the water boards in California. There is a portion of the Federal Clean Water Act that requires all states and tribes with implementing authority to have enforceable numeric water quality criteria for a set of pollutants called priority toxic pollutants. Depending on whose list you're looking at, there's either 126 or 129 of those. They were pollutants that US EPA identified back in the 1970s that had priority for their control actions. So this portion of the Clean Water Act requires any state or tribe with delegated Clean Water Act authority to have numeric limits enforceable for these pollutants. Well, back in, let's say 1990, if you looked at all the regional board basin plans and the statewide water quality control plans, most of these priority toxic pollutants weren't covered at all. The metals, by and large, were, but most of the organics were not. And so the State Water Board, in consultation with EPA, did a statewide water quality control plan adoption. They adopted two plans, the Inland Surface Waters Plan and the Enclosed Bays and Estuaries Plan, that included statewide water quality objectives for the priority toxic pollutants that would essentially fill in the gaps so that statewide we complied with this portion of the Federal Clean Water Act. We'd have enforceable water quality objectives for all priority toxic pollutants. Well, there were a couple of missteps there, and not all of them were covered. And California wasn't alone in being out of compliance with this requirement of the Federal Clean Water Act. And in the mid-1990s, early 1990s, US EPA just got tired of waiting for the states and the tribes to act. So they promulgated standards on various water bodies throughout California and a number of other states in a ruling, a regulation called the National Toxics Rule. So in 1992, that was added to the regulations implementing the Federal Clean Water Act, and it essentially filled in the gaps, the missing numeric enforceable limits for those remaining priority toxic pollutants for which the state had failed to act. And there were some waters in California covered by the National Toxics Rule. But a number of dischargers got together and made the case to a judge that the statewide water quality control plans adopted by the State Water Board, the Inland Surface Waters Plan and the Enclosed Bays and Estuaries Plan, didn't follow appropriate procedures because they didn't adequately consider economic impacts. So one of the things when you adopt a water quality objective under Porter Cologne, you have to consider the economic impacts. What's it going to cost and to whom? It doesn't require a cost-benefit analysis, but it requires the cost of adopting those objectives to be brought to the regional or the state water board so they were aware of those costs prior to actually adopting the water quality objective. And these dischargers made the case to a judge effectively that the State Water Board had failed to do that. and the judge ordered the State Water Board to rescind those 2 statewide water quality control plans. So where did that put California? Back out of compliance with this provision of the Clean Water Act. So there were negotiations that went on between the State Water Board and US EPA, mainly over that word reasonable. Because for the state to fill in the gaps, we have to determine that the objectives we're going to adopt are reasonable to achieve. EPA said, no, it's got to be protective regardless of whether it's achievable. So we finally came to an agreement that let EPA adopt the numbers. So in the year 2000, EPA adopted a new regulation under the Clean Water Act called the California Toxics Rule that first of all said, for waters that have National Toxics Rule criteria, we're going to leave those in place. For all other inland surface waters, enclosed bays and estuaries, here are the California Toxics Rule criteria, enforceable numbers, for all of the priority toxic pollutants. Okay? So we're back in compliance now because of the California Toxics Rule. So what did those dischargers get by bringing this up to a court? They wound up with numbers more stringent than they would have gotten had they just left things alone. I think it's kind of sweet. So anyway, we now have 2 ways of getting enforceable water quality standards in California. We either have water quality objectives and beneficial uses in the basin plans adopted by the water boards, or we have California Toxics Rule and National Toxics Rule water quality criteria plus the beneficial uses in the basin plans also equals a water quality standard. Okay? You got to comply with both of them, both kinds. So as I mentioned earlier, whenever we have enforceable numbers in California, we have to have an implementation plan under Porter Cologne. So that state board took on that job and adopted the state implementation plan. Of course, it's got a much longer title here, which you can read yourself, but the abbreviation is SIP for State Implementation Plan, that essentially said, how are we going to comply with these California Toxics Rule criteria? And that was adopted by the State Water Board in March of 2000. It's been amended since. And it first of all said, okay, well, we can have time schedules for compliance. There are certain dischargers who might not be able to immediately comply with all the CTR criteria. We can give them time schedules in our NPDES permits. It also allowed the regional water boards to implement mixing zones within which we would not require compliance with the CTR criteria, but at the edge of the mixing zone, we require compliance, as long as there was a zone of passage for aquatic organisms and some other things as well. It would establish a procedure by which we can take the California Toxics Rule criteria, the numbers in the receiving water, and back calculate effluent limits, how much can be in the discharge. Part of that has to consider water effect ratios. It's part of the process of determining effluent limits. And also, how do background levels come into play? When we're looking at the discharge of, let's say, copper from a sewage treatment plant, there might be copper coming down the creek that it's discharging to from background levels. How is that considered in determining effluent limits? And then also, there are analytical methods that are specified for determining compliance with the CTR criteria, and analytical reporting levels. What are, how precise and how low do the labs have to get in their analytical work to determine compliance with the CTR criteria? So an appendix of the SIP actually sets out what are called minimum levels, which are the reporting levels that labs are required to meet. Yes?
Does that mean contact time retention, CTR, or what's this?
CTR, California Toxics Rule.
Oh, I'm sorry. I was thinking that you were talking about something about the mixing zone for some reason.
What I probably should do with this class is have an acronym sheet. That might help. I'll make one up and I'll post it online. A lot of acronyms in this class. Sorry about that. I tried. If they're not clear, at any time, interrupt me and say, now what was that again? That's fine. It's fine to do that. Okay. So also in the CTR, EPA realized that there were some places in California that already had enforceable numbers for some of the priority toxic pollutants. And so there'd be a conflict between a number that was adopted by a regional board and the CTR number. Well, which one applies? So EPA laid out 2 scenarios. If EPA has already approved what the state has done, then that supersedes the NTR or the CTR, as long as they are protective of the same things. There were some exceptions that EPA found. For example, in the Sacramento River, the basin plan water quality objectives were only protective of acute exposure because they were instantaneous maximum criteria rather than something that had a longer averaging period. So EPA said, fine, you don't need to comply with the CTR acute exposure criteria, but you got to comply with the CTR chronic criteria in those waters. In San Francisco Bay, there were specific water quality objectives that in some cases were more or less restrictive than the CTR, but because EPA had already approved them, the CTR criteria would not apply. And then the other scenario is, let's say a regional board has adopted a new water quality objective and EPA is still reviewing it for compliance with the Federal Clean Water Act. During that period, the more stringent applies between the CTR criterion and the state adopted number. Okay? So it's important to know adoption dates. And if you go into your basin plan web pages on each of the regional water board sites, you'll see usually the approval letters from EPA that say, okay, yes, we've approved this one, we've approved that one. It's important to know. You've been sitting a long time. So we're going to take a break. Before we do, are there any pressing questions? You need a break. Okay.